All right, so this video today, guys, is going to focus on writing equations from a word problem. We're not trying to solve the problem. We just want to represent the problem in a mathematical equation instead of in the English sentences that they are. All right, so the first thing that's really important is we need to figure out what our variables are, and then we need to highlight to represent where our equations will come from. All right. So this first question says, Jack collects baseball and football cards. He has 125 cards total. The number of baseball cards he has is 5 more than 3 times the number of football cards. Write a system of equations to determine how many baseball and how many football cards he has. So the first thing we need to do is we need to recognize that B is going to stand for the number of baseball cards. And F is going to represent the number of football cards. Now we're going to get 2 equations from 2 separate sentences. So take a highlighter and you're going to highlight this sentence. He has 125 cards total. That's going to give you one of your equations. Then take another color. And the number of baseball cards he has is 5 more than 3 times the number of football cards. That's going to give us the second equation. Okay? All right. In order to say he has 125 cards total, you're just going to say all of the baseball plus all of the football is equal to 125 cards. That's it to that equation. If the number of baseball cards is 5 more than 3 times the number of football cards, the first thing you need to notice is the word is. The word is always gives you an equal sign. The number of baseball cards is B, is equal, 5 is 5, more than means add, and 3 times football is 3F. The only other thing we need from that is if this word than is in the question, then you need to change the order of the 5 and the 3F. So we have B equals, 3F will come first, and then add the 5 more. That's it. Number 2, Jerry deposited $160 at the bank in $1 and $5 bills. He deposited 3 times as many $1 bills as $5 bills. Write a system of equations to represent how many $1 and $5 bills Jerry deposited at the bank. We're going to say that X represents the number of $1 bills. And then Y will represent the number of $5 bills. Now grab a highlighter. I'm going to highlight Jerry deposited $160. That's going to give me one of the equations. The other equation is going to come from the sentence that says he deposited 3 times as many 1 as 5. All right. This first thing, $160 is a total. So I have something, oh man, whoops. My bad. Okay, so he totals 160. The 160 comes from the $1 bills and the $5 bills. But if I just leave the equation like that, I'm talking about the quantity of them and not the money worth. If 160 is what they're worth, I have to count by their value. So I have $1 for every X, and I have $5 for every Y. If he deposited 3 times as many $1 bills as $5 bills, I don't know the total, and I don't know the word is, so I don't have an equal sign. If that's the situation, you need to ask yourself, which one does he have more of? If he deposited 3 times as many 1 as he did 5, then he has more $1 bills. So I'm going to say the $1 bills X is equal. Then on the other side of the equal sign, I need to say how many more does he have? This says he has 3 times the other. All right, Janice is selling tickets to a concert. She has sold 79 tickets. The number of children's tickets she has sold is 1 more than twice the number of adult tickets. Write a system of equations that could be used to find the number of children and adult tickets. C is going to represent the number of children tickets. and A is going to represent the number of adult tickets. All right, then grab a highlighter. The first thing that's going to give me an equation is the total 79. The second equation is going to come from the number of children's tickets is 1 more than twice the number of adult. So that will give me this one, and yellow will give me this one. Okay. Excuse me. Okay, so if I have 79 total tickets sold, then the number of children's tickets plus adult tickets is 79 tickets. If the number of children's tickets she has is, remember that word is gives you an equal sign. So children's tickets, C, is 1 more than twice adult. This word than, though, means you're going to flip the order. So I have C equals 2A plus 1. All right, next. Don has a rectangular lot that has a length 5 times greater than the width. The perimeter of the lot is 120 feet. Write a system of equations that could be used to solve the length and width of the lot. So L is going to represent the length, and W is going to represent the width. All right? Okay, then we know if the length 5 times greater than the width, that's going to give us 1. And then perimeter is 120. Okay. If he has a length 5 times greater than the width, that means the length is bigger. So length equals 5 times the width. Now the next part is kind of confusing. We know that the total is 120, but in order to write the rest of the equation, we have to know about perimeter. Remember, if you have a rectangle, perimeter means you're going to add up all of the sides. So there's 4 sides. There's a length, a width, a length, and a width. So if I add all 4 of those sides, I have 2 widths added to 2 lengths. That's how I get the 120, okay? All right, Mike gave his friend 53 coins that totaled $3.65. He gave him nickels and dimes. How many nickels and how many dimes did Mike give his friend? First of all, we know N is going to be the number of nickels, and D is going to be the number of dimes. Okay? Then the difference with this one when we highlight is instead of highlighting 2 separate sentences, all of our information this time is given to us in one single sentence. So I don't have 2 separate sentences for 2 equations, but in that one sentence, I do get 2 totals. So I'm going to have one equation that totals 53, and I'm going to have a second equation that totals $3.65. So that one's a little different because it's not 2 separate sentences, but it's still 2 separate totals. All right, to get 53 total. If he has 53 total coins, that's just all of the nickels plus all of the dimes is 53 total pieces. You're going to count them by ones. But if my total is $3, oh man, I don't know how I keep doing that. Sorry. Okay, if the total is in the money, so dollars and cents, that means my variables, N and D, both need to be written in dollars and cents. So nickels is 5 cents, so 0.05 for every nickel. And dimes is 10 cents, so 0.10 for every dime. So if your answer is money, you need money for both your variables also, okay? And that's it on that one.